Hello. Hi, everyone. My name is Eric. Nice to meet you all. I'm going to tell you why you don't want serverless. Oh boy, this is going to be fun. I'm going to have to dodge the rocks and the cabbages and the tomatoes. All right, that's a pretty spicy take. Everyone loves serverless. It's like the best thing ever, right? It's like the most awesome thing ever. So spicy, very spicy. Well, you probably don't want serverless. Okay, I'm already backpedaling a little bit. What I'm not saying is that, serverless is a silver bullet, and it's not certainly evil. It's not bad if you use serverless. There are a lot of problems that are great for serverless, and a lot of the problems I'm going to talk about today can be solved with enough engineering. Just depends on how much engineering you want to do and how much knowledge you want to gain about how cloud providers run your thing. So it just depends on a lot. So really what I want you to do today is think about your tools. And, nowadays I see every problem, at least in my company, and others, being solved with serverless. It's like, oh, we have this problem. Make a function. We have this other problem. Make another function. Pretty soon you have thousands and thousands of functions. And you're like, maybe these aren't the best things to solve these problems. If everything looks like a function, maybe it's all serverless? I don't know. So really what I want you to think about today is when you're picking a tool, know the limitations of your tool. And Maslow's hammer really applies, I feel like, to all technology. We have a lot of hype around a lot of different technologies now. It used to be blockchain, now it's AI, now it's, serverless. But really think about what you're doing, and why you're doing it. And does it solve your problem, actually? So I use the cloud. I promise. I use serverless, I promise. I don't want this talk to be me complaining, but it's going to be me complaining. I'm going to be yelling at the cloud for most of this talk. Okay, why should you listen to me at all? Well, I'm a full stack dev. I've been working in the educational software industry for about a decade. We build things on multiple clouds. We service millions and millions of students, tens of millions of students a day. I've worked in every cloud there is. I'm a new dad, so I've got dad energy. So that's a reason to trust me. I make video games for fun. So that's another reason you should listen to my talk about serverless. And shameless plug, if you want to make video games in TypeScript, I make a TypeScript game engine called Excalibur.js. Not important, but it's fun. I love cats. I run long distances for fun. I have a marathon coming up that I'm not trained for, so that'll be fun. And then I do math and physics for fun. So there's that. That's why you should listen to me. So back to serverless. What do I mean by that? It's pretty nebulous. Everyone has a serverless offering in their cloud. Every cloud has something called serverless. And there's a few common characteristics. So this is what I mean by serverless. First off, it spins down to 0. So when you're not using it, you're not paying for it. All of your code goes down. Nothing is running. That's one quality. Another, function level. This is a little squishy, like it depends on what you count as a function. Is 1,000 lines a function? Is 100 lines a function? Up to you. There's no hardware infrastructure to manage or upgrade. That's nice. That's a pain in the butt. I used to do that a lot, and it's no fun. And it's no fun when it breaks. So that's a great quality. Serverless is metered, so it's pay by usage, whether it's compute, time, resources, etc., or a combination thereof. They seem to be metered. And a lot of them, not all of them, a lot of them seem to be event-driven or purport event-driven architectures. That seems to be serverless. I literally read every one of these cloud offerings to try and figure out, okay, what do they all have in common? This is kind of what I came up with. So, okay, what am I really getting at? What am I really angry about? Okay, I'm talking about functions. So I'm talking about AWS Lambda, Azure functions, Google Cloud functions, Cloudflare workers, that's hard to say, Vercel, Netlify, what have you. A lot of these have the same problems. Some of them have different trade-offs because they're built differently. Okay, so what are the problems? So here's the 6 things that I think are wrong with serverless and why you might want to consider not using it. I think it's not actually that simple. I don't think it's actually that simple to use, and I'll tell you why. I think it doesn't have great developer experience. And this is the biggest hill for me at my job, is if it's hard for developers to write software in it correctly, then it's not a good tool. It makes more bugs than it solves. Everyone talks about cold starts, and we'll talk about that a little bit, and performance. There's an incentive misalignment with cloud providers. Cloud providers want to make money, and so do you. There's this myth of concurrency, like these will get you huge, huge numbers. Maybe. They might. They're cheap. I don't think so. They might be, depending on what you're doing. You might get a really exciting bill one day. All right, let's dig into simplicity. So I argue that serverless is a leaky abstraction. What I mean by that is you really need to know how Azure built their function environment, how AWS built their function environment, how Google Cloud Functions built their function environment in order to adequately use them. They're not portable across different clouds very easily because they have different performance characteristics. One thing that is leaky is database connections are broken by default in like every cloud provider. So why is this happening? Well, it's because you get a new execution context, usually, for each invocation of your function. And for traditional databases like MySQL, Postgres, SQL Server, you have connection pooling problems. So these execution contexts spin up for every request that comes into the Lambda, eats up a connection, the connection doesn't get returned, and then suddenly your database has no connections anymore, and your database falls over. That kind of sucks. Now, this is solvable. So, if you run into this or you plan on connecting to a MySQL or Postgres database, there's solutions. There's a lovely package by Mr. Jeremy Daly. You're going to hear about him a lot today. He's got serverless MySQL. If you are using Postgres, there's a lovely tool called PG Bouncer, which is kind of a reverse proxy for connections. Really cool. So I really recommend PG Bouncer. Amazon will sell you a thing called RDS Proxy, and it's PG Bouncer wrapped up real nice. But you can do that. But you need to buy those things. You need to set those things up. It's just broken by default. You want to use a database, probably. The other thing you could do is use a cloud database. So Cosmos, or maybe Mongo, or another database that's not so concerned about connection pooling, DynamoDB, and the like. So these databases don't really care about connection pools so much. Maybe that's your solution. So just something to think about. I usually want to connect to a database. When I said when you invocate a function, you usually get a new execution context, well, that can cause some interesting stateful problems. This has happened to us. I'm not going to say how or when or who, but it's easy to accidentally hoist state into your execution context. Maybe you're running a Python Lambda and you have a global variable somewhere, or a C# Lambda and you have a static somewhere. I'm not saying this happened to us, but if you have a static somewhere, it can easily hold on to state in between executions and start corrupting data in your database. If you were counting on each invocation being a separate context, a separate instance of your function, it's not. So you can easily corrupt data across sessions. So it's just something to keep in mind. And it's, you just have to be aware of the leaky abstraction, that you are borrowing compute from a cloud provider that is trying to reuse it. It's good. It's good that they're trying to reuse execution context. That's like not a cold start. That's a warm start. But then you have this problem in the good case. You accidentally share state. So maybe that's not a problem for the senior engineers, but it might be for the junior. Not great. You know, cold starts are a problem, but a lot of people have written little things to ping their Lambdas to keep them warm, which arguably is really wild that you have to do, isn't it? That we're being sold a service that you have to write a thing to keep it warm. Isn't that outrageous? There are things to solve this. You can, in AWS, there's something called provision concurrency. You can pay them extra money, and they'll keep it warm for you. That's great. Azure has different service plans. I think it's the premium tier or the dedicated. Another one of my beefs is that the Azure pricing documents are incredibly difficult to read. But you can keep them warm by paying your cloud provider, or you can spin something up to keep them warm. And the fact that you have a warm and a cold function is this weird leaky abstraction now that you need to know about to design good software. What if, everyone's favorite language here is C#, obviously, but what if your favorite language is like Zig, like mine? I love Zig. Or Lua, like game devs out there, we love Lua. Or Rust, what if you're really into Rust? This can be tough depending on your platform. AWS makes this incredibly challenging if you want to run something that is not supported. Lambda layers are extremely, extremely painful. I challenge you to go and read their documentation and implement your own custom runtime in a day. Go for it. If you do it, I'm proud, because I wasn't able to. The other thing is some of these functions will force you into a custom runtime if your function gets too big. So if in Lambda, for example, if you have a function that's more than 50 meg, you need to make your own custom runtime. And guess what happens with Python all the time? That. Especially if you're using like pandas or you're using like a math library at all, you easily bump into, oh, I need to make my own custom Lambda layer in order to run my supported Python code. The next thing is, like, if you're doing your own custom runtime, the errors that come out of it are incredibly opaque. Like, you're like, random socket error, and you're like, I don't know what that means in the context of this function because it's a leaky abstraction. If you like WASM, I have good news. Cloudflare will let you run anything that compiles to WASM, so it actually makes it really easy. So Cloudflare is great for that. So if you can build it down to WASM, you can run it in Cloudflare really well. If you like C++, no cold start problems. You got C++. Azure is actually really great here in terms of making custom runtimes, because all you need to do is respond to a web request and stand up a server. And that's how you make a custom runtime. Stand up a server, listen on a port, you're good to go. It's really great. So Azure's really good in that context. OK. Leaky abstractions, lots of fun. Security. These are not all of the security problems. I mean, software has security, lots of security problems. And these are not unique to serverless, but I feel like these are easy to have happen. If your function is publicly known, they can denial of service it. So you have a bad actor. They decide, OK, I don't like this company for whatever reason. I don't like you for whatever reason. I'm going to go ahead and hit that function as hard as I can, and either in Amazon hit your concurrency limit, which affects your entire account. Your entire account can no longer run functions. Yikes. Or we can denial your wallet. Say you have, it's like, OK, I've cut a deal with Azure. I've got my dials turned all the way up to 11, so I can scale as far as I want. I'm going to denial your wallet and hit you so hard and get you a giant bill. And maybe you can negotiate with Azure, and they'll fix that for you. And they probably will. But that's scary that they can do that. What if you're just me? What if I'm just me, and I get denied of wallet, and all my money gets drained out of my bank account? That would be sad. The other thing that can happen that has happened, I won't say who or when, but improper access control is really easy to do when you put something in a Lambda or in a function if you're not careful. In AWS, for example, you configure permissions for your code to reach out to other AWS services. Well, the blast radius suddenly gets really high when it can poke other cloud services. So this is a problem in other software too. It's not specifically for Lambda, but it's for functions, it's a little easier to do. You now have an incredibly high blast radius for code that you deploy there. Okay. Developer experience. It's pretty great. Developer experience is pretty good. Honestly, like you can deploy stuff really fast. It's awesome. You can run stuff locally. That works pretty good. The tough part is testing. Yeah, you can't really test it. You can write unit tests, and those work pretty well. I've been very successful writing unit tests for Lambdas and for Azure functions. But how often do unit tests predict working software when it's deployed? I have like very low confidence that my unit tests predict that my software will work in production. The logic might be right. I have very high confidence that the logic is correct, but I don't really know if it's going to work. This is the same for any kind of software that you're running. In your CI, you usually stand it up in a container. You have maybe 1 or 2 end-to-end tests just to make sure that it boots, right? That's really hard to do. You can do this manually. There's a great tool that is around, has been around for a while called AWS Lambda for .NET. It'll stand up like a little web page for you, and you can poke at it as if you're sending it like different events like that you would see in Lambda. Azure has something similar. There's the new SAM CLI, which is great. Does a similar thing. You can poke at it. There's Serverless Offline, which is a third-party tool that you pay for. I think this plugin is free, though. Same deal. You can test it locally, manually. But none of these run in CI, as far as I know. If they do, let me know. So a lot of what happens at my job is we deploy and pray. I hope this works. I'm going to just throw it into a dev environment. And maybe that's not a problem for you if you have, like, you are the only one in your dev environment. But if you have a shared environment, like a shared AWS account that is your dev environment, that could be disruptive to other teams, especially if you're a core service. That might not be good. I was looking at recommendations for testing Lambdas online, and one of the recommendations was don't. Just deploy it. I'm like, no, don't do that. Please test it first. So you're kind of stuck in either deploy or pray, or test it manually and hope you caught everything, That's not great. Should you? All right. Churn. So this might not be a problem. It's probably a good thing for like software security. AWS and Azure force you to upgrade your stuff. That's great. That's great for security. If you have 2,000 Lambdas and Azure functions, it is no longer great. If you are a company, it is a gigantic burden to go and upgrade all those things and make sure that they're working. And then here's the Python chart for Azure. Environment variables are awesome. .env, yeah, I use that for a lot of stuff. It works great. Doesn't work so great in AWS. If you want to put environment variables in there, you have a 4 kilobyte limit. And you don't know that until you hit it, really. So you might be like, OK, I got to put a cert in here for whatever reason. I'm going to put it in an environment variable. I'm going to put maybe my private key in there so I could check a signature or something. Like I'm getting a message off of a queue. I'm checking a signature. I have a cert in there to check that sig. Oops. I easily bump over 4K. I have a lot of environment variables. Like, I just have a ton. Like, maybe I have hundreds. Then I'm over the 4K limit, and it doesn't work anymore. You want to use secrets? Go ahead and buy our secret solution from your cloud vendor. The other thing that's really tough with DX is observability is incredibly challenging in serverless environments. A lot of it requires code modification, so you need to go and pepper your code with decorations, whatever framework you're using. to get clear insights into how things are going. And I 100%, if you're using serverless and you don't have observability, it's going to bite you. You 100% need to have observability in serverless. You can maybe get away with it in other things without. I love New Relic. I love OpenTelemetry. Definitely dig into OpenTelemetry. That's the free open spec. All of these other providers cost money, but they all work with OpenTelemetry. Tracing request flows in serverless is really hard. And if you have a request flow that goes through a message queue, you now have to decorate your message with the trace context so that you can trace those messages as they flow through your system. It's incredibly difficult. There's easy pitfalls and anti-patterns. So the good, the bad, the ugly is a great blog post. I recommend you look at it. This is the thing that happens is, I call it the lambda lith. That's when you have a huge C# service and you decide, you know when we moved to the cloud, we put everything from our VMs into containers and we just shipped it and it was not good. Same idea. We take our entire C# service, we throw it into a function, and we hope for the best. This doesn't work so well because of JIT. So large code JIT, you normally pay that cost amortized over time in a container. So containers running for a period of time, usually maybe hours, days. You get to pay that cost over that runtime of that container. Now you have each new execution context, you're paying the cost of your JIT every time. Also, you might have a large code download. That also impacts your cold starts. So if you have a lot of code to download into this Lambda, it's going to take a long time. And then your blast radius, again, for security is a lot higher because now you have this huge service that now has permissions to God knows what in your thing. So it's very important that your permissions are tightly scoped. The orchestrator. This is really challenging to debug. You have like one Lambda or one function, and all of the things go through it and bounce out of it. You have super complicated dispatch. You don't know what's causing the problem or where it's coming from, and your logs are a mess. So don't do this. Things you can do, though, I think Azure has state machines and durable functions. Those are things to look at. If you need to do like a workflow, definitely look at those. AWS has something called step functions. Look at that. Or get a state machine library and do that if you need to do a workflow. Yeah, very complicated stuff. I don't know if I need to tell you why this is bad. But try to debug this. Where's the problem? Like if I said, oh, the problem is in there somewhere, how do you find it? One, how do you find it without observability? Good luck. Observability will give you a chance, so observability is very important. You want distributed traces for sure. This is madness. I mean, honestly, you could, instead of like the function symbol up there, we could just put, containers, microservices, same deal. This is not unique necessarily to functions, but it is easy to do in functions. It's easy to do in microservices. Don't do this. And if you need to, observability is your helper here. This one will cost you. I call this one the invocation loop. This is like your classic infinite loop, but instead of it using CPU cycles, it chews through dollar bills. So say you have like a function that hits some blob stores something, but oops, it triggers an event on your function, and then it goes and puts something in your blob store, and then it just goes and goes and goes, and you go to sleep, and then you wake up the next day with a very large bill. Oops. Now this is kind of contrived, and some cloud providers now have protections for this. In fact, AWS can detect simple stuff like this. But if you have a more complicated loop, bouncing through different services, this might happen to you. So beware. This is just why. Just have one, This just makes it more complicated. Also, you now have latency every hop. You have latency every hop. You chew up, if you're in AWS, you've now just, for the price of 1, you've used up 4 concurrency. You've used up more execution. If you're in function land, you're charged gigabyte second. Yeah, more expensive. This one is kind of a no-brainer, but don't block, because you're on the meter, right? You're charged per gigabyte second. This is going to cost you if you sit and wait. Fire and forget. Do things in parallel. Don't block on stuff. Just get in and get out in a function. All right. Whew. A lot of stuff. OK. There was a lot of time to get to cold starts, so I have a lot of other beef besides cold starts. Cold starts are not great. Very not great. So these numbers might be out of date, but they're probably in the right ballpark. This is from Mikhail, his blog post on cold starts. A really awesome blog post. I encourage you to read it. But every cloud provider has cold starts. Like, that's just what's going to happen. It's part of the problem. So if this is important for a customer workload, you might want to rethink it. You want to maybe use a service. You might want to use something else. I wouldn't have a customer-facing workload because you're going to have cold starts. It's just going to happen. So if this is, or maybe your customers don't care, that your Azure function takes 5 seconds. Maybe that's OK. But this is a moving target. It's getting better. The talk yesterday about what they've done in Azure Functions, they've done a lot of work to improve it. So definitely keep an eye on them. You can do a hack so you don't have to spend as much money with provision concurrency and keep a function warm. Azure's documentation, you can make a App Insights availability test and ping your function every 5 to 10 minutes. This is in their documentation. You can pay, like I said before, a lot of money to keep them warm in AWS. The other thing that's wrong is you don't know how long they're going to be warm for. It depends on how busy Azure is that day or how busy AWS is that day. You don't know how long things are going to be warm. So you can't really count on it for performance characteristics if they're important to you. This is in their documentation for AWS. Your Lambda service retains execution context for a non-deterministic amount of time. OK. Code gymnastics. Well, you got to do stuff to your code to work around cold starts, especially if you're in like a JITted or an interpreted language. I talked about Cloudflare using WASM. You can use that to help get ahead of things in Cloudflare. In .NET 3, we have ready to run, which is kind of like partial ahead of time compilation. What does that do? That's converting a lot of your code into native code so that it doesn't need to be JITted, and then having some IL. So that's what ready to run does. And it's a little more flexible because you can have IL still. And it can do things on Linux 64. I think it's only the latest Ubuntu. And then Windows 64. There's full ahead of time compilation, and I think it's in .NET 7, 7 plus. Don't quote me on that. But this is full AOT. You don't get a JIT. You just ship a binary. But there are limitations. You can't load assemblies on the fly. Some regular expressions won't work. There's a few other things. You can't do COM. You can't do system reflection emit. You can't do runtime code generation. There's a huge list. There's a big list of things you can't do. But it really does help with cold starts, like significantly. This is like you're getting close to like C++ territory, single-digit millisecond cold start. So this is a thing you might have to do. But this is gymnastics now that you need to do to make this work. There is some hope for JavaScript. This was just posted in February. Amazon has been building their own JavaScript runtime to help with cold starts, which is awesome. The LLRT. Yeah, so that's cool. So there's some hope. They have some, some really cool stuff. They have a warning up there. It's experimental. They have some really impressive numbers for like P99s. Not terrible. In fact, I'd say you probably could serve customer workloads with those cold start numbers. That's pretty awesome. So I've been saying things about P99s. What is it? It's not an exercise routine, so it's not P90X. So P99s are the 99% of your requests are better than a certain number. So these are really great for knowing if your, averages lie to you. So on average, our requests are 100 milliseconds, but every 1 out of 100, they wait for a minute. Whew. That would be really rough to be that customer. So P99s are really great for understanding if you are operating within your bounds. So like, we like to stay below 200 milliseconds. P99 below 200 milliseconds, probably okay. And in their documentation, 1% are going to be cold starts. Ouch. So you got to design for that. Okay. Whew. A lot of complaints. This is going to be my conspiracy theory section. It's okay, because I brought my tinfoil hat. I don't know if y'all have Weird Al here, but he's awesome. Cloud providers are a business, not your friend. And we are a business, usually, and we would like to hold on to our money. So if you've ever tried to read the pricing guide, either for Azure or for AWS, they kind of read like a multi-level marketing scheme of different numbers and tiers and requests. And tell me which one of these is actually an MLM chart versus a cloud pricing chart. Because the one on the right is an MLM one. They look the same, don't they? All right, conspiracy theory. We'll sell you the fix. They're broken, but it's okay. We got this provision concurrency we can sell you. Oh, it's broken, it's okay. We got this proxy thing for the database stuff. We'll sell you secret manager and parameter store for the environment variable problem. We'll sell you tracing with X-ray, but then you got to use X-ray. We'll sell you Azure Monitor, which is actually pretty great, by the way. I guess I'm not so sad about that one. But if you're not in Azure, then it doesn't help you. These functions are kind of vendor lock-in as a service because you write the code, and they're all tied to the SDKs of that particular platform. So if you write some Azure code that's using the Azure message queuing systems, you can't port that to Lambda without rewriting it. The SDKs are completely different. The behavior, the call patterns are completely different. So, like, even if you did your best to isolate yourselves from your dependencies in this cloud platform, you're going to have to rewrite big portions of your code. Ouch. Okay. Concurrency. There's a lot of literature out there. There's a lot of people that are like, oh, it's infinite scale. It's not. It's finite. But if you have infinite money, it can maybe get close. And for example, in AWS, your limit for concurrency is 1,000, and you have to ask for more. That capacity limit is not clearly documented, and we have to do crazy stuff to get around it. Like, I have to make a new AWS account for each application to get around it. And Azure functions kind of have the same thing. You have to make a new plan for each function in order to not have noisy neighbors. Consumption plan, that is. So in AWS, this is how concurrency works. So you pay for the initialization time, and see, now at 6 and 7 here, we got warm functions, but now we're at concurrency, what is this, concurrency 7, concurrency 5? Okay, that's not so bad for one. We have a cap of 1,000 by default. And you can ask them for a bump. The first one's free. They'll do it for you without asking questions, but try to do it the second time. So in the default concurrency, if I have requests that take 500 milliseconds, I can only do 2,000 requests per second in my entire account. I need to make new accounts. And in fact, like, it's really important that your code is fast, because as soon as your code is taking longer than 500 milliseconds, the amount of stuff you can run gets lower and lower. Say you have a really, underperforming team or underperforming function, it's now chewing up capacity for your entire account. So that's not super great. You know what's really great at concurrency? Web servers. Web servers are really good at this. I can do way more than 2,000 requests per second in .NET. And in fact, the tech and power for ASP.NET, they have it at like 7 million. So that's pretty cool. And that's maybe not fair because they're probably running on benchmarking hardware and whatnot. But I can guarantee you I can do more than 2,000 requests per second in a container. And I'm not going to get capped by the account. Isn't that wild? So as a thought exercise, if you needed to do the tech and power thing in AWS, like you need 8,407 AWS units of concurrency for your entire account. And then you could just do that one thing. That's fun. So Azure is harder to understand. I mean, AWS has like weird limitations, but Azure is a little harder to understand. Their documentation is pretty dense and pretty hard to sort through. They have 2 true serverless plans, and those are the consumption plans. There's the current consumption plan, which will spin down, it will spin down to 0, and it'll spin up. And then there's the flex consumption plan, which is in beta until the end of this year or earlier. But you'll pay for it. By default, they spin up a 2 meg execution environment, or excuse me, 2 gig execution environment. You pay per gigabyte second. That gigabyte in there is the amount of memory that you have during function execution. So keep that in mind. If you want to do warm stuff, I think you need premium or dedicated. If you want to do custom runtime, that's what container apps are for. So Azure concurrency is a little different than AWS one, so that's not confusing at all. But their concurrency actually makes more sense to me. Azure concurrency means how many of an execution task can I fit in a context. So if I have concurrency 1, it's the thing on the left. I know it looks like a die. But AWS is one to one. So if you have concurrency 1 in Azure, you're looking like AWS. If you have concurrency 4, you have 4 tasks that can run in parallel in one execution context, which is good because you save money, because you're stacking up more work in one context. Might be bad if you have stacks or shared state maybe, but yeah. Okay, are they cheap? Maybe. Straight from the horse's mouth, Amazon Prime Video saved 90% by switching to VMs, which is mind-blowing. They switched off of microservices and functions to VMs, and they saved 90%. The call is coming from inside the house. It's inside the house. They're switching themselves. They're not using their own stuff. And they were, it made, okay, so to be fair, that's hyperbole. To be completely fair, it made sense for them to do it at the time because they wanted that burst scale. They wanted to be able to burst. And so they were willing to trade the cost of that for that burst scale. But then, after their service was successful, they were able to refactor and go back down. But if you're not willing to trade that cost, maybe not. Yeah, they went to a monolith. Okay, I did these numbers. This is my chart. There's an Excel document that drives this. I used the AWS cost calculator to chart how much per million per request per second Lambdas will cost you. And they're really competitive here, If you are in the super low request per second situation, they're really competitive. Definitely look at a Lambda instead of using a container, or a server. Wow, they're pretty good. The Lambdas start to get a little more expensive the more memory you have and the longer they take because, again, Azure and Lambda are priced identically. So when I say Lambda or I say Azure, you're built the same. They're super competitive with each other. So, so really it comes down to how much memory you use and how long does it take. So if you're going to do something in functions, do it fast and do it in a little bit of memory. And just for giggles, if you were doing 1 million requests per day, this is what it would cost you per month for a service. And this is or for a Lambda with an API gateway. The one at the bottom is if you had 1,000 Lambdas in your company, that's $1 million a month. That's $1 million. That's a lot. But you know, if you had 1,000 of these small ones, it's still a lot. And if you're using this to solve all your problems, it adds up. Yeah. Okay. It's a lot of complaints. You know, I saved the money to the the end. This is also really annoying. Like, okay, I've got this service. Now I'm talking to all these cloud services that are also metered. They're also costing me money. I've got API gateway. I got to pay for egress. Ugh. Ugh. Surprise! Your money is gone. This was just posted on LinkedIn 5 days ago. This poor man shipped an app called Kara, and he got a bill for $100K after a couple days. This is Vercel, so you know, like, this is running on Vercel, but it does make you kind of tighten up a little bit, doesn't it? It's like, what if my thing is suddenly popular? Is that okay? I don't want it to be popular. Wait, what's going on with me? I want it to be popular. So, like, what do? Do you throttle yourself? Do you move off of serverless to control costs? Do you have to ship with a business model that can support this? Like, how do you move fast and break things and not go bankrupt? You know, yikes. Okay. Total cost of ownership. You got lock-in. You got maintenance. You got this hidden complexity now that you have to deal with that you need to know. And then these hard to predict costs. They really are kind of iffy, aren't they? Okay. I've complained a lot. There are good things. All right. This has all been a one-sided argument. No, there hasn't been a serverless defender up here be like, you're wrong. It's good for everything. And it is good for stuff. I'm not going to say that it's bad at everything or that you don't want to use it ever. I use it. I have on purpose used serverless. What? The person up here complaining about it for an hour has used it on purpose? I have. I have used it on purpose. I know you can't believe it. I have used it on purpose. All right. Here's one thing to consider. And maybe that example with Kara with the 100K bill is maybe the counterpoint to this. But it lets you go fast. You can get stuff out there without a lot of hassle. You don't need to set up like a build pipeline. You don't need to set up a lot of stuff. You don't need to set up like a Kubernetes cluster. You don't need to set up a container cluster. You don't need to set up load balancers. You don't need to do this or that. You can just get stuff out there really fast. And that might be important, especially if you're trying to disrupt. So speed to market, don't discount that. That is a strength. It lets you turn capital expenditure into operational expenditure as fast as possible. So, hey, if you need to do that accounting, awesome. It's really good for latency and sensitive stuff. So if you don't care about the latency, it's awesome. It's so good. Like, if you have a non-customer facing app, say you got internal apps, and you don't care if your internal customers have a cold start every once in a while, that's fine. Or you pay for low provision concurrency. Or you keep like a small number warm. Something that doesn't break the bank. That's totally fine. If you have something that doesn't need instant responses, like if it's not part of your largest contentful paint, maybe it's okay to have something running in the background. Maybe it's telemetry. That's fine. Use that for telemetry. If you can do it fast and in low memory, it makes economic sense. Queue-based systems, they are really good at these because you don't need to run fast. You don't need to run, you don't need a lot of throughput. You can just chew on them slowly. This is awesome. They're really great at this. They're really good at doing out-of-band processing. So, say I need to do something later, we'll just fire up a function. It'll do something. Fine. Low throughput applications. So let's say I'm doing some small batch processing, less than 15 minutes in AWS, less than 30 in Azure. If you got a batch process that's quick to complete, do that. If you've got some sort of ETL that you can run on a schedule and it runs in less than 15 minutes, might be a way to do it. Or you can chunk it, might be a way to do it. If you need low-cost developer environments, like we do, because we have a lot of developers, this makes a lot of sense because it spins down to 0, right? And developer environments are super low throughput, right? How many requests per second do you have on a developer environment? 2 a day? Super low throughput. And in that chart that we saw, they're super competitive in that area. Build systems. Vercel and Netlify have really capitalized on this for static site generation. Use these for static site generation. They're really good at that. Bursty stuff. I will admit, it's really good at bursty stuff. For example, there's a game on, and then a commercial for pizza shows up, and then everyone orders a pizza in the country at the same time. That's where this is going to be great, because Azure has a huge fleet of machines, and they can handle vampire traffic like this, where they get the big teeth that hit you right in your wallet. But if you're willing to pay for it, this is a solution for that problem. If you're Domino's Pizza and you need to run crazy requests all at the same time, this might make sense. You need to hit, you can't wait for containers to spin up. Or you're unwilling to provision to peak. Or you don't know, you can't predict. It's unpredictable. You can't, maybe you can't predict when this happens to you, but it does. This is a great opportunity. Okay, so I've held you captive. Do you want serverless? Does every problem look like a nail? So I really want you to think about your tools before you use them. There are some downsides, but there are some upsides. So we're ending on a positive note. I complained for an hour, and maybe it's okay, maybe it's bad. But, consider your tools. There is hidden complexity. So just be aware that you'll need to understand the leaky abstraction. There are some developer experience problems, but you can maybe get around them. Cold starts are a thing. They're never going away. So work around them or do the code gymnastics to make them, minimize them. The cloud provider is not your friend. They're not your buddy. Concurrency is key, and a lot of this is going to be performance tuning. It's going to be negotiation, and it's going to be experimentation. They're not cheap. They can be if you're in the right use case, though. So make sure that you have a use case that is well suited, or you're willing to pay that cost. That is a trade-off that you're making knowingly, not being surprised by it. You are prepared for that cost. And there are plenty of other use cases that are good. I didn't list all of them. I can't know everything. All right. Thank you, guys. That was a lot of fun. Tusen takk. And I don't know how much time I've got, but if you want to ask questions, we can do that later.